Ever pondered how it would be to predict the future? Well, in the world of quantum mechanics, that's what scientists strive to do with particles. Imagine a mathematician's crystal ball, a formula that could predict the future state of a quantum system. That is the essence of Schrödinger's wave equation. Now hold up. Before anyone panics at the sight of a complex mathematical equation, let's break it down into smaller, digestible parts. The wave equation is a partial differential equation, and it's the backbone of quantum mechanics. It's written as h pas equals e pas. At first glance, it might look like a secret code, but each symbol carries a particular meaning. The h stands for Hamiltonian operator. This operator is responsible for taking our wave function pas and turning it into a new function. The Hamiltonian operator represents the total energy of a quantum system. Speaking of paps, you might be wondering what this fancy symbol stands for. It's the Greek letter psi, and in this context, it represents the wave function of the system. The wave function is a mathematical expression that describes the state of our quantum system at any given time. Now on to the other side of the equation. E is the total energy of the system. This isn't a new function, but rather a number that scales the wave function. So, the equation h equals eps is saying that when we apply the Hamiltonian operator to our wave function, we get the same function back, just scaled by some amount. It's a bit like saying that if we take an object and spin it around, it's still the same object, just a bit dizzy. Schrödinger's wave equation is a tool that allows physicists to predict the probability distribution of a particle's position. It's crucial to note that it doesn't tell us where a particle is, but rather it gives us a cloud of probabilities, telling us where we might find the particle. In summary, Schrödinger's wave equation is a fundamental equation in quantum mechanics. It describes the changes over time in a physical system, where the system is represented by the wave function, pas. The Hamiltonian operator h in the equation operates on the wave function to produce a new function. The total energy, E, is a scalar quantity that scales the wave function. The understanding and application of Schrödinger's wave equation have been instrumental in various fields, from the development of electronic devices to the understanding of chemical reactions. It's a testament to the beauty and complexity of the quantum world, a world that is as fascinating as it is mysterious. So, the next time someone mentions quantum mechanics or Schrödinger's wave equation, remember, it's not just about a cat in a box. It's about the past, present, and future states of the tiniest particles in the universe. And that's something to marvel at.